What is responsible for hurricanes, tornadoes, winds, thunderstorms, rain, snow, and all the other kinds of weather we experience here on Earth? Believe it or not, it is something very far away from our planet. In fact, it is at the center of our solar system and is called our sun. The energy from the sun powers the weather that we have here on Earth. Our planet is surrounded by an atmosphere of gases that extends hundreds of miles above the surface of the Earth. This atmosphere is made up of gases, liquids, and even very small particles of solids, such as dust and dirt. The atmosphere is thickest in the lowest level called the troposphere. This is where all our weather occurs. The energy from the sun travels through space an incredible 93 million miles to reach our atmosphere. Some of the energy is blocked by the atmosphere when it hits dust and water particles. This energy bounces back into space. Most of the invisible ultraviolet waves of energy that can harm plants and animals are absorbed by the protective ozone layer that surrounds our planet. These ultraviolet rays are very harmful, and in space, our astronauts have to wear special spacesuits to protect themselves because they are away from the protection of our atmosphere. Part of the sun's energy reaches the Earth and is reflected or bounces back to space. Some of the energy isn't reflected, but instead is absorbed by the soil and water. Things that are dark in color easily absorb or soak in the heat energy. Things that are light colored don't absorb as much heat. They reflect it away. Here is a simple demonstration of that idea. Here are two different containers. One is painted white and the other is painted black. Water is poured into each container and a thermometer is used to record the temperature. After the cans have had a chance to sit in the sun for a while, the temperature is read again. The dark can has absorbed more heat energy because its temperature has increased the most. The Earth absorbs the heat energy from the sun and heats the air above it. Different parts of the planet absorb different amounts of heat energy. The polar regions reflect a lot of energy because of all the white snow, while other places absorb much of the heat that reaches them. When the air above the surface is heated, it expands and rises. Warm air is lighter than cold air, and so it rises. That's why these balloonists use big burners to heat the air inside the balloons to make them light enough to float in the air. As air is heated, the molecules that make up the air spread apart and take up more room than cooler air. There are less air molecules inside the balloon, so it floats in the surrounding cooler air. So air above warm surfaces of the Earth is heated and rises. As it rises, cooler air comes in to replace it. This is what causes air movements we call wind. How much the surface of the Earth heats up depends on how many hours of sunlight the area receives and the angle of the rays from the sun. The Earth is tilted on its axis. This tilt is responsible for our seasons and the difference in temperatures. The Earth stays tilted at about 23.5 degrees. As our planet goes around the sun, it is sometimes tilted in such a way that the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted towards the sun. During that time, our country is having winter, and countries in South America are having summer. At other times of the year, the reverse occurs, and we have summer and the southern hemisphere has winter. During winter, the angle of the sun's rays are greater than during summer when the rays are more straight on. We can illustrate this idea with graph paper and a flashlight. We'll pretend the flashlight is the sun, and the light from the flashlight are rays of sunlight. When the light strikes the graph paper from straight on, the light strikes only a small area of the paper. When the flashlight is at an angle, the light spreads out over a larger area. When it spreads out, it has less effect on any given point. The same thing happens when rays of sunlight strike our planet. The area at the equator receives rays that are more direct, and therefore temperatures in this area are warm throughout the year. At other places, the angle of the rays depends on what time of year it is, and whether the Earth is tilted away or towards the sun. Actually, during summer, for the United States, the Earth is farther away from the sun than during winter. What determines the seasons is the tilt of the Earth as it orbits the sun. Water is very important to the workings of the atmosphere. On Earth, we have a certain amount of water. It is recycled in a complex system called the water cycle. Energy from the sun heats the water in the oceans, lakes, and soil, causing some of it to evaporate. This means the water changes from its liquid form into a gaseous form called water vapor. This water vapor rises into the atmosphere. As the water vapor rises in the atmosphere, it becomes cooler and begins to change back into a liquid form. Clouds form, and if the cooling continues, the water vapor may condense into water droplets or ice crystals. As the cooling continues, the water returns to the Earth as precipitation. This may be in the form of rain, sleet, hail, or snow. Even though 3/4 of our planet is covered by water, only 3% of this water is fresh water. Let's pretend that all the Earth's water is represented by the water in this 1-liter flask. 1 liter is equal to 1,000 milliliters. Out of that 1,000 milliliters, 972 milliliters is salt water in the oceans. We can't drink that water or use it to grow crops. That leaves 28 milliliters as fresh water. However, 23 milliliters of that fresh water is found as ice, and 4 milliliters as underground fresh water. Out of all that water, only 2 drops from this medicine dropper represent the amount of fresh water in lakes and ponds. Only a very small drop shows the amount of fresh water in the soil and air. When water evaporates, it is clean and fresh because only the water vapor rises into the atmosphere. Other particles, such as salts and dirt, are too heavy to evaporate. This cycle has been operating for billions of years and is necessary to keep our planet's supply of fresh water continuing. You can probably see that even though the Earth is covered with water, only a small part can be used for drinking and growing plants. It is important that humans don't do anything that changes this life-supporting cycle we call the water cycle. Now, let's look at how weather moves from one place to another. Meteorologists are scientists who watch weather closely and try to determine what the weather will be like in a certain area. Weather conditions change from day to day because of the movement of air masses. An air mass is a large body of air that forms over a certain area of our planet. It may form over land or water, or maybe it will form over cold areas up north, or warm areas near the equator. The air mass takes on the characteristics of the area it forms over. This means that air masses forming over water are moist, while air masses forming over land are dry. Air masses forming over cold polar regions are cold, while air masses forming over the tropics are warm. Air masses move from one place to another because the Earth isn't heated equally. Remember that our planet is tilted on its axis. Because of this tilt, the sun's rays strike the Earth at different angles, and therefore the Earth is heated unevenly. Warm air rises when it is heated, creating low pressure. Cold air masses have high pressure because there is more air in a given spot in cold air masses. If we could see the air molecules in a column of warm air and a column of cold air, we would see that the cold air column has more molecules. That's because when air is heated, the molecules spread out. The cold air mass moves into areas of low pressure, and air movement results. On a weather map, we can identify air masses by the capital H for high pressure and the capital L for low pressure. Weather forecasters and meteorologists can predict the weather for an area of the world by looking at the movement of air masses. You may have felt this movement of air while at the beach. The land heats up faster than the water, so the air above the beach rises, and the cooler air above the water moves in to replace it. We feel a cooling breeze from the water. At night, the opposite happens. The water holds on to the heat longer, so the air above the water rises, and colder air above the land moves out to the water. As air masses meet, a boundary between them forms. The air masses don't mix, but one pushes the other along. These boundaries are called fronts. A cold front forms when a cold air mass pushes a warm air mass. The cold air is denser than the warm air and causes the warm air to rise quickly. As the warm air rises, the moisture it contains begins to cool and condense. The water vapor in the air changes to liquid droplets and clouds form. Thunderstorms may form because of this action. Thunderstorms are violent storms capable of much destruction from high winds and lightning. At any given moment, there are about 2,000 thunderstorms occurring around the world. Thunderstorms usually don't last very long, but they can be a real threat to people and property. Lightning, which often occurs during thunderstorms, can be very dangerous. You must remember to seek shelter inside a building. Don't go under a tree. Try not to be the tallest thing around. Get out of the water and away from a pool or beach. Large thunderstorms, called supercells, may spin out a series of tornadoes. These are very violent, localized storms that can have winds as high as 300 miles per hour. Winds from a tornado can lift railroad cars or automobiles, rip boards and roofs from buildings, or uproot trees. Most tornadoes last only a few minutes, but there have been monster tornadoes that have lasted for hours and traveled 200 miles on the ground. Tornadoes may be tops when it comes to wind speed, but in terms of overall damage potential and sheer power, hurricanes, typhoons, and cyclones have everything else beat. These are storms that form over the warm waters of the tropics. These storms are given different names in different parts of the world, as shown on this map. Tornadoes have stronger winds, but only affect a small region and usually last only a few minutes. A hurricane has winds of more than 74 miles per hour, but will stretch over an area of more than 100 miles. Also, hurricanes can last as long as a week. Besides high winds and rain, flooding is also a problem with hurricanes. Hurricanes form in tropic oceans where the water temperature is at least 80 degrees. The hurricane is made up of many thunderstorms that begin to circle around a central area. This central area is quite unusual because it remains an area in the center of this massive storm that is completely calm. It is called the eye of the hurricane. You can see hurricanes clearly when looking at satellite photos. This meteorologist has used information given to him by computers hooked to weather stations around the country to prepare a weather report for his viewers. He must look at weather maps and study conditions in different places to make a forecast for the area he lives in. He prepares maps and charts to help explain what he thinks will happen over the next few days. When he gives his weather forecast, he stands in front of a green screen that can be made to show the maps and charts he prepared earlier. This way, he can point to things and areas of interest. Weather is important for everyone. We need to know how the weather might change so that we can dress properly and make careful plans for how our day will be spent. Listening to weather forecasts on television or on the radio is a good way to start your day.